So this is the basic schematic. This is one of 18 channels on the ChAnalyzer. It runs on 5-volt power. It's got a solid state optically coupled relay, which is the heart of the device. And the way it works, there's a grounded test probe here that's fed ground through a normally closed switch. This switch is located on the grounded test probe, and on the tip of the probe is a very fine needle. And the way it's designed to work is under a microscope with the electrode facing up where you can see the tips of all the micro wires in the array. Each one of these circuits would be connected through an omnetics connector through 1 to 16 channels of the recording channels, and there's also 2 ground channels. So all of the connections will be tested with this system. And so you can see there's a 220 ohm current limit resistor, there's an internal LED and an external LED, and they're in series. And so when the grounded test probe makes contact or conductivity through one of these channels, there's the electrons flow through the LEDs, both LEDs, and when they do flow, they electrically connect, they activate this device, and they connect pin 5 to pin 4. And when that happens, it latches on. Pin 4 then applies a constant ground to the same circuit that you applied the momentary ground, and that keeps it latched until you remove power. And this device, this switch here, the normally closed switch, which is on the test probe, that is what you use to disconnect and delatch the device and reset it for the next channel. And so you'd go through and work under a microscope, systematically checking each wire of the microelectrode, and looking up and recording which channel it is and sketching its location in the array related to the other 16 channels. And these are 6-pin dips, and there's a lot of different devices that will plug in and work. This one's the LCA 717. I've also used the PVA 612s, which I think are now obsolete. But there's quite a few different devices that are designed to work in this application. So this is the prototype circuit that I used to develop the idea. It uses it's based around this chip here. It's a 6-pin dip, and I like to use these a lot. They're optically coupled solid state relays, and there's a lot of different devices that actually will fit in and work for this one. But this happens to be the LAC 717. And what's internal here, there's on this side of the chip here, pins 1 and 2, that's an internal LED inside there, the anode and cathode. And on this half of the chip is the power side, the power handling, pins 4, 5, and 6. And the way this chip works is when the LED is activated and conducting, it makes pin 5 electrically connected to pins 4 and 6 simultaneously. And so in this case, I'm using it to latch on when I get a conductive path between the electrode tip and the probe. And so I've got 5 volts coming in through a 220 ohm current limiting resistor, and it goes through the anode to the cathode internally, and then externally there's a anode to cathode on the LED. And this wire here, this represents a connection on the omnetics connector. That would be pins, the 16 recording electrode pins, and then there's actually 2 ground pins, so I'm actually checking those as well. So there's going to be 18 of these circuits. And so you can see when this circuit becomes activated, this is the ground, represents the ground probe. When you touch one of the tips of the microwire, you'd be doing this under the microscope, looking straight up at the tip of the array. You briefly touch it and you'd get a latched on LED. And you can see that out of the corner of your eye, and then you can look over while it's latched and record which channel it is and where it is in location to all the other electrodes in the array. And the way this latches is I've got pin 5 here is connected to ground. And so when this side of the chip conducts, it basically connects pin 5 to pin 4 with a ground, and that comes around and holds this pin low and makes it stay low until you remove power. And so the way on the device I've built, there'll be a momentarily normally closed switch built into the probe, and once you're done with the information, you simply push the button momentarily and it removes power and the device unlatches, and then you can go and touch another microwire tip and get another channel indication. And this way, if you don't get a channel indication on a wire, then you know there's an opening. Maybe the silver paint's not conducted, or there's a poor solder joint somewhere. Most of the time that's not a problem, but it's good to check it. This is mostly to determine the location of the channel on the array.